Hello everyone. So what we're going to be working on today is this tie rocket problem. So question 12 here says the figure shows a design for a tie rocket. The main body of the rocket is based on an ellipse. So this main body here is based on an ellipse. Half the minor axis of the ellipse is 40 millimeters long as shown. So half the minor axis from there to there, or from the center to the radius of the minor circle is 40 millimeters. Then it says the line AB is a tangent to the ellipse from A. So this here is a tangent line running from A to B. So there's a construction involved with that gives you this tangent from A to B. The line ED is a tangent to the ellipse from E. So this is the same thing here this side. So there will be a point of contact on B, and we can just bring it across and we'll create another point of contact at D. So the next step then in the rocket problem is to draw a horizontal line across the page first. And then according to the question here, it's 60 degrees from the horizontal, this line which the major axis lies on, 60 degrees from the horizontal. So like the 36 degree set square, I'm just starting anywhere at all on the horizontal line, just draw a construction line here. And then if we call this the radius 65, there's a point on this here and it's radius 65. We come up 25. So 25, 97. And 40 and 26. So we're 40 here and 26. That'll bring us to the focal point. That is the focal point there. One of the focal points. We call it F2. Up the top there. So we got this one F2. We don't know where F1 is yet. We've no measurement on the drawing. So we have to figure out the length of the major axis first. So the only thing we have at the minute is half the minor axis. So half our minor axis is 40. So let's measure it out here in this. So 40. And then the centre line, we'll create one now in a minute. This is our minor circle. Right, we've that much. So what we can actually do now is establish where F1 is, because we have a centre point here. So we can reach this focal point here with the compass. Try and get as accurate as you can. And then back, strike an arc on the major axis. And then we have F1. Some of these questions just test you to figure out certain dimensions and things like that. So then we can get our minor axis. Big construction line again, don't need to go too heavy there. And since we have this point and this point, we can now establish the length of the major axis, or we can get the radius of the major circle. So if we put the point of the compass here, reach to F2, that distance there is half of the minor axis, or radius the major circle. So we can work there with our major circle. Now we have something to work with. So what I'll do is I'll just extend this onward, forward, and back this way. Now the best thing to do at this stage is to actually turn the sheet, because we're dealing with a line here that's 60 degrees off the horizontal. And when we start dividing up our circle, we'll have to start off at such an angle and then to do our 30-60 degrees and that. So what I'll do is I'll pause the video and untape the sheet, and what we'll do is we'll leave this major axis vertical. So what I did here was I lined up my set square at the bottom of the sheet down here, and I just moved this camera here because you won't be able to see the bottom of the sheet. And I'm dealing with down here. This was our original horizontal line, but now the horizontal line is at 30 degrees, or the whole sheet is at 30 degrees to the drawing board. So to leave it easier now to divide up this here into 30 and 60 degrees. So this is what I'll do now. Hard to see that there. I can see it, but I doubt if the camera pick it up and just get it a bit heavier there. Right. So now we can just go the ordinary way. From the centre, O, we can call it O. Centre, out to hit the major circle, down, out from the minor circle, minor point. So out from the centre to the major, drop a line. Actually, you want to be very careful here. You have to nose on something here. With this here is the major axis. So it's very easy to go around because we've things turned here. So this is the major axis. So what we're actually doing here is the orientation has changed. So we're going out from our 0 point, and these are 2 points in the ellipse here, top and bottom of the ellipse. Here's another point in the ellipse, another one here. So we're working in this area. So we can bring out from the major circle and then up from the minor circle, because we're actually working at 90 degrees to what we usually would work at. There's 2 points there. There are 2 points. another 2 points here and here. Just another thing to mention there, if you have the drawn set up properly on the sheet, or the orientation is right, these 2 points here should actually be straight across from each other, or they should be there should be perpendicular 90-degree angle here. Just note that. Or 2 points. So what I'll do here is I'll stop the video and I'll sketch in the ellipse here. So I've sketched in the ellipse shape there. So the next thing is, just put them up here. We have these 2 circles here, 2 arcs. The center point of this R65 arc is here. So we're just down 20. So it's where we started. We started on a horizontal line going across the page, and that's where we started. That can be our R65. You can roughly put that in for the minute. So we started down here. As you can see that there, 25 to that dot. So that was our starting point. So I've just set my compass here to 65. And you can scribe an arc there. Light will be okay, there's no point in going heavy for the minute until we get our 2 arcs sorted out. That's one there. The other one is, well, we have to worry about the tail piece next of the rocket. The tail piece is down here. That tail piece is constructed by so this is 50, so we have to go 25 either side of the point where we created this R65. Put the compass here and scribe an arc which will be 50 long to hit this point down the bottom. So I'll do that please. So if we come out 25 either side of this point, we can go heavy there now because that's going to be the line that we need. Set the compass to 25 then, or sorry, to 50. Full length of this line you need to go. Yeah, so 50. And then just scribe an arc here, go to the other side, scribe an arc again, and that there is our point for the tail of the rocket. Then we can just heavy in the arcs up to that point. We can put a bit more weight on the compass this time, because these are going to be permanent lines. That's the tail of the compass there, or the tail of the rocket there. So this line here then is 25 up from where we started. We can put that in and heavy it. So 25 up. I already have that marked here. So we'll just go 2 construction lines here from the tail up like that. And then we can heavy this line in here then. And heavy the 2 that come up to meet it from here. Right, I can label these now. We have point A, point E is here, there's a tangent line crossing here somewhere. The question asks, or the question says, the line AB is a tangent to the ellipse from A. So there's a tangent line coming from here, from this point A here, and hitting the ellipse at some point of contact. We don't know where the point of contact is yet, so we'll have to make up a construction for that. So the way we do that is, we start from A and we get that distance F1 there and straighten an arc. We get the full length of the major axis beyond F2 now. You make sure it's right to where it needs to be. The full length of that major axis of the ellipse, go to F2 and then straighten an arc to intersect with the first arc that you drew from A to F1. So we've a point here and a point here. What we do next is connect that point and the intersection of the two arcs back to F2. And where that intersects the ellipse, I have a pen here to highlight it, that point there is point of contact, or tangent. What we know now is another point of contact here on the side of the ellipse, point of contact again. So now we connect up our two tangents to the ellipse. From A, these can be heavy now as well. And from E to this point. They're labelled in the drawing too. They're called B and D. This is point B, point D is here. Right, so the next part we have to do is the curve or circle. It's the tail wing of the rocket. So we already have this one done right, but we have another point here that we've created when we swung our two arcs, or 50 arcs. They hit on this point, so that's going to be the centre point for our next arc. These are all outside the body of the rocket, so when we're having them in, there's no need to cross over into the body of the rocket. There's no advantage to do that. And both are 65, so set the compass at 65. So we already have this one. No point here. I can label those 2 points just so we're sure as well. That there is point X, and this here can be point Y. Just the centres of the 2 arcs, that's all. So we actually go back to our original one and have it in from here. This point here where the 2 arcs meet. So back into Y again and have it in this part section. Just to make sure that our arcs are long enough, our light arcs are long enough first before we held them in. We go back to Y here. So we have an intersection point here now, right there. If this arc wasn't long enough, we wouldn't, but we do, so they're intersecting there. We can heavy this in. Go back to X and heavy in this one. So now, the last thing you have to do with the question is these circles. And these circles couldn't be drawn actually previous to getting point of contact here and here, because we don't know the radius or the diameter of the circles. But we do now, because we have the point on the minor circle for the centres of these smaller circles, and we have the line crossing over from the point of contact. So we have a measurement now for those smaller circles. So where those smaller circles lie, where the centres of them lie, is on that point there, on this point, and on the centre. That's the 3 centre points of the 3 circles that we need. So we'll just get the distance here. I think it's around 15 mil, but it's could be different in some people's drawings depending on the accuracy of the constructions that we did before. So here, one of our circles. Make sure you keep enough pressure there on that point of the compass there. This is our last circle. Right, so that's that drawing finished. The trickiest part of that drawing is to establish the length of the minor axis first. That's the first thing you have to do in that. Establish the length of this minor axis, or major axis here. This is the major axis from top to bottom. That's done by getting your compass. We have to create this minor axis first, and then where that touches the minor circle, put the point of your compass to F2. Whatever distance that is, don't move the compass, put the point back on O and describe your major circle. The other tricky part is from A to F1 you strike an arc to get your construction for the tangent. You get the full length of the major circle, the full diameter of the major circle, put the point of your compass there, strike an arc to intersect with the one that you've made from A, bring a line from F1 to touch that, from F2 to touch it, and then wherever that intersects the ellipse is your tangent point from A to B, and that can be brought across then just for point D. Thanks a lot for that.